Hi everyone, Francis is here. In today's video, we will discuss the forms of rational functions. You can think of it as a summary of all what we have done in the whole of the partial fraction video series. So, whenever you see a partial fraction, any partial fraction you see, it must take any of these 5 listed forms. Or when you make reference to these 5 listed forms, you can actually tell how to treat the denominator. Okay, so if you have a partial fraction that is of this, that has a denominator, a linear denominator, or a quadratic function that can be factorized. When you factorize it and you get x minus a and x minus b such that a is not equal to b, that will mean you have 2 distinct linear roots. So here's a form of how to write the partial fraction. On the left, you write it this way: a over x minus a plus b over x minus b. Now the second one here is when you have the denominator such that when you factorize, you have 2 repeated roots. When you have 2 repeated roots or n repeated roots, like I said in one of the videos, how you do that is just you write the denominator, you express it as this, as a over x minus a plus the next one will be b over x minus a raised to the power 2. So if this were n, you keep increasing it to plus up to n. You keep increasing the denominator b, c. You keep increasing the denominator. The next one will be c, and you increase the next denominator will be x minus a raised to power 3, and you keep increasing it in that order to x raised to power x raised to the power n, x raised to power x minus a raised to power n. Okay, so if you have a function whose denominator is of x minus in fact this, if you have something of x, if you have a denominator of x minus a, if you have a rational function whose denominator is x minus a, x minus b, x minus c, you simply express it as this. Yes, a over x minus a plus b over x minus b plus c over x minus c. Okay, so here we have is an example. Number 4 here is an example of where we have 1 linear and 2 repeated roots. So this is how you express that. You express it as a over x minus a plus b over x minus a raised to the power 2. Okay, and that is, and the last one will be plus c over x minus b. Then the fifth, the next form would be if you have a denominator with one linear and 1 quadratic. The quadratic is such that you cannot this is a plus. Here the quadratic ax squared plus b plus c is such that you cannot factorize, and that means that, or in the sense, you can't factorize in the sense that you can't find an x whose power is real, I mean an x whose value is real for this function, for this quadratic function. So you express that as a. We express the partial fraction as a x minus a plus bx plus c over a x squared plus bx plus c. So bear in mind the numerator, once you express the denominator here as ax squared plus bx plus c, then the numerator must take a linear factor in form of bx plus c. So at this point, I think we have come to the conclusion of everything that has to do with, I mean, all forms of rational functions you can see, and we have also treated on the left hand side here the forms of the partial fraction, or how to express this rational function as a partial fraction. Thank you for watching, and see you in the next one. Bye.